Hi everybody, this is Mr. Claus, and what I'm holding here is a test tube that's just filled with air. Now you know that air is a mix of oxygen and other gases. What we want to do is we want to find out exactly what percentage of that air in this test tube is oxygen. Now I've already measured the volume of the test tube by pouring in water, pouring it out into a graduated cylinder. That volume of water also represents the volume of air. So I know the volume of the air with the oxygen in it. What I want to do is take the oxygen out of the air. So I'm going to light this candle. The candle is just placed in water. I've colored the water blue so you can see it more easily, but you won't have colored water in your lab. Now what I want to do is I want to use that flame to consume or get rid of the oxygen that's in the air in this test tube. To do that, I'm going to take the test tube, flip it over and put it right on the flame under the level of the water, so I have to do it quickly, but not all the way to the bottom. And what should happen then is the flame will consume up the oxygen and it should go out because it won't have any oxygen left. So let's do it. So you see the flame go out. Now when the flame goes out, see how water traveled up in the tube? The water traveled up in the tube because the flame used up the oxygen and something had to take up the space the oxygen was in. So that water up in the tube represents the volume of oxygen that was in that air in the test tube. To mark that volume, I'm just going to grab the test tube right to where the water came up to, and I'm going to be really careful to keep my finger in the same spot the entire time. So this part of the test tube represents parts of the air that were not oxygen and were not consumed by the flame. This volume of the test tube represents the part of the air that was oxygen in the air. I know the original volume of the test tube. I can find this volume by pouring in water and then dumping it out into a graduated cylinder, so I know the volume of the air that was not oxygen. I can subtract that from the original volume to get this volume here, which is the volume of the oxygen. And then I can turn that into a percent. I'll have the percentage of air, the percentage of oxygen that was in that air.